Well, hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and this video is going to be what I call a tidbits video. It's probably not going to include any machining in this, but I'm going to cover a couple topics, three topics that of things going on here in the Tin Barn that didn't necessarily warrant their own video. Showed you just a little teaser clip in the introduction of this of the power feed on my surface grinder. I did that about 9 months when I got the surface grinder. When I got the surface grinder, I had in mind doing that. That was one of the projects that I wanted to do, along with some of the other accessories that I've shown in some videos before. But I put together a little teaser video of that power feed, and I got thick skin, but I took a lot of flack over that. I mean, I was told, no doubt about it, that thing is not going to work. Not going to get any kind of finish. Just everything that could be wrong with it was wrong with it. And like I say, I got thick skin. I just decided not to post a video, not to make a video on it. But I've received numerous emails, text messages from folks that have my contact information, and also comments on videos where the power feed was shown in there. And now all I want to know, is it something I bought? Is it something I built? How does it work? Etc. So I'm just going to include that on the tidbits. There was no real hard machining in this, just cutting out a few aluminum pieces for a mount and for a block, and pitman arm, those kind of things. So I'm not going to show you all the detail of building it, but I will show you each piece. Before I do that though, I want to give you just a little bit of background on the chuck on this surface grinder. When I got it, I mapped it out, I measured it, and there's a slight valley in the very center of my chuck. It's 3/10 of 1/1000. Now, let me put that in perspective just a little bit, especially for those that may not be familiar with measuring in thousandths. And keep in mind, I'm a hobbyist. I'm not making parts for the International Space Station or anything like that. I use this surface grinder primarily to just pretty up pieces, if you will. But I'd show you if I had any hair, but a human hair is about 4/1000 of an inch. Now, being 4/1000, let's split that hair 4 ways. Then you got 1/1000. Now, split that 3 ways. So 1/12 of the thickness of a human hair is what my chuck has, a little valley in the middle of it, just a little divot in the middle. It was there, it was that way when I got the chuck. Like I say, I mapped it out, but I did not feel like then, nor do I feel like now, I can get it any better than that. I've not taken the vise off of the table. It's just like I got it, other than being cleaned up, and I'm extremely satisfied with the finish I'm getting on it. I'm going to show you a short video clip that I did just within the last couple of weeks when I decided I was going to do this, feature this in a tidbits video. But I mapped out the chuck again in 5 locations, and it still showed that I had about a 3/10 dip in the very center. Remember, that's 1/12 of a human hair. But in this clip, I'm going to show you how I mapped that out, how I determined that, and then I'm going to do a grind using the full length of the chuck, the full throw of this power feed, and then we're going to measure the difference on that. In addition to that short video, then we're going to come back and I'm going to take each part of this power feed, show it to you, and explain it to you. After we're done with that, we're going to move on to a couple other items here in the Tin Barn. One of them is an outboard spider for the lathe that I received some questions about. I've had it on the lathe probably close to 2 years now and never really talked about it, but do get a lot of use out of it. And then there may be a couple other tidbits that we can include in this video as well. So check this video out, and then we'll come back and talk about the individual pieces of the power feed. Okay, hopefully that video helped alleviate any concerns you had about it absolutely not working at all. I'm happy with it, but what I want to do is try to explain a little bit about the pieces that's involved in this. And each one of them, I'll try to get you a little close-up picture of it and include in the video. The first piece I dealt with was this block over here. Everything on this is made out of aluminum, but made this block, and I had to be extremely careful when I was drilling and tapping into this cross slide here. The ways for that cross slide for this on the Z-axis, the in and out, are very close up under here. So again, I had to be very careful. There's 3 mounting screws over here that I didn't get into those ways at all. Let me grab myself a little cloth here because there's plenty of oil under there. So another thing about this, I do not run this without turning the wheel on, because when the wheel is running, when the motor on the surface grinder is running, it's pumping oil. And I don't want to be moving this table back and forth and not be pumping oil. To connect this block to the motor down here, I have a turnbuckle, if you will. I call it a pitman rod, but it has a swivel link on both ends. I made this part. I just got these turnbuckle ends off of McMaster car. They're 3/8 18 fine thread. This is simply a piece of aluminum rod through here that I threaded for each end to adjust the length with. Now I can disengage the power feed entirely. And just let that arm hang, and then I have complete manual control just like I did before I added the power feed on. That is nothing more, again I'll get a close-up picture of this, but it's nothing more than a sleeve pinned to this end of the pitman rod with a slot cut in it. And a turn notch to lock in, for that screw to lock into. All right, then we move on down. We have, I'm going to jump over this part and come to this. This is simply a series of 3 pieces of aluminum flat bar, one mounted into the end, screwed into the end of the table. The ways, you got plenty of room in here. You just don't want to get into any feed. This particular table is a cable feed, which means there is 0 backlash. It doesn't have a rack and pinion or drive gear lead screw in it. It is cable. Mounted that in. This plate up here is screwed through this plate, and this is the mount for the motor. I'm going to show you the motor that I'm using, or show you one that's like it. These are Bodine Electric Company gear motor. It is a 24 volt DC, which means of course it's reversible, 1/15 horsepower, 67 RPM. I'll get you a close-up of this tag as well. I find these occasionally on eBay. I have bought probably close to 10 or 12 of these over last couple of years. I use them to have built the power lifts for the Z-axis on the on my milling machine. I put one on it. I've built several for other folks, and this again is a backup that I've got here. But it's 67 RPM gear motor. It has 42 pounds of torque. Okay, it's out of frame right now, but on the wall up here is a power supply that I put together, speed controller with a power supply. Now to adjust the throw on this, as you can see, I've got this arm pulled up tight in this mount right here, in this sleeve. So the stroke on it, again, let me get the oil pump going. All right, I have this arm slid in. Let me say one other thing. This speed control, I said that was 67 RPM motor. On that power supply and speed control I've got, this is about 43%. So it's running probably about 30 RPMs now, which is plenty fast for the grinding. Again, back to the stroke length. I have this arm pushed all the way in, so I'm getting the shortest stroke possible now. And on my mill, or on the lathe chuck, that is approximately half the length in the center of the chuck. I've got a center mark here, and it's going from here to here, so that's about 6 inches of the chuck. Now this is just a clamping device. Again, no special milling at all, or no special knowledge necessary to build that. But now we'll slide that out to the end. And now you see that it will take just about the full length, or it will take the full length of the chuck. It has a very smooth transition on this end. On this end right here, there's just a little bump, but as long as I'm always certain that that bump happens off the work, it's not affecting the finish whatsoever. Very seldom do I have anything to grind that requires the full length of the chuck anyway. Now I'm going to show you how this is all put together. I'm going to take these pieces apart right quick. Okay. Again, this is just a pitman rod here. This is the notch that the other end goes up into with the screw, tightens down right here. This slide rod, which adjusts the length of the throw, looks like a piece of 3/8 by 1 inch aluminum flat bar. And on this end down here, I added a 1/2 inch thick piece just to offset it. That is nothing more. It was put on with some spring pins. And that just gives room for the throw clearance. Looking back over here, if you do decide to build one of these for yourself, or some facsimile of it, number one thing you'll need to keep in mind, and I had to learn this through trial and error, is that the center of this end of the pitman rod needs to be on the same plane as the center of your motor shaft. So when the rod goes all the way there, it's at full length one direction. Back this way, it's in full length in the other direction. So straight up or straight down should be halfway your chuck. Let me take this little piece off right quick to show you how that's mounted. Motor has a keyway in it, and this is nothing more than an aluminum block, homemade motor mount, broached out, bored and broached a keyway with a clamp. Hindsight, I did not need 4 screws. 2 screws, obviously not in your slot, but 2 screws would have been plenty enough to hold that. So I'm going to assemble this back together right quick, do a quick little grind with it, and then we'll move on to the next tidbit. All right, now let's just take a little grind. I'm going to take 20 thousandths over, step over on the Z-axis. I've got my, where I put the power feed back together. It's a little over half the length on about a 4-inch block there. So let's get it back touching. This is at live speed right here. For those of you concerned that I'm going to beat myself to death with this handle over here, I believe it'll be okay. All right, I'm going to step the speed up to about 8x now and go ahead and finish this surface. All right, as I said to begin with, I'm happy with the power feed. It does what I wanted it to do. I do not detect any, I'm not able to detect any loss of accuracy in using it. Your mileage may vary, but I hope that answered some questions that some of my viewers had regarding it. The second most watched video on my channel is one titled to the effect of a lathe spider. And this is what I made in that. This goes in the jaws, sits in the 3-jaw chuck, up against the back of the chuck. Makes a nice offset for holding thin material or material that doesn't go up in the jaws much. I'll put a link up, up here to the video where that's made. But a lot of people, when they think of a lathe spider, they think of something on the outside. And one of my viewers, Howard from the western part of North Carolina, recently sent me an email asking if I had a outside spider, external spider, on my lathe. This is a Precision Matthews 1127. The VF is variable frequency. This is a 220 3-phase motor in here with a built-in VFD. And the LB stands for large bore. I can get, I think it's 1 3/4 bore through this, through the spindle, chuck right on out to the outside. And relatively speaking to the size of this lathe, 11-inch throw, that's a reasonably large bore. So a spider on the outside is even more needed if you're going to turn large stock, longer stock. What this, of course, is used for, if you've got a piece of long stock that extends, well, I don't think I got my lathe jaws open right now, but that extends on out here. You need something to support this. Don't, if you're turning very high RPMs, this will basically shake your lathe apart if it doesn't bend the material first. And all this is here are just 1/4 bolts that are in this sleeve that's out here. Let me take this apart. Let me take this cover off, and I'll show you how this started out and explain the process that I went through to make this external spider. All right, I've got the cover off the gear end of the spindle of the lathe. This is the way the lathe originally came. This, of course, is the spindle. Had this lock nut on there. I took it off. And I determined that this threaded part right here was 48 millimeter by 1.5 pitch. So I took a piece of stock, took a piece of round stock that I had. It could have been solid, but it was close to that. Turned it down to the 48 millimeter, and then turn cut 1.5 pitch threads in it. And what I did this right after, within probably a month of getting this lathe. So I had next to zero experience cutting threads, especially cutting threads to something that I didn't have a corresponding piece to match to. So I would cut the threads some, take this nut off, see if I can take it off this time and not drop it, and then keep testing until they were a match. Now, for whatever reason, this has been about 3 years ago when I did this, and for whatever reason, I've hung on to this piece. And when Howard asked me about this external spider, I actually knew right where to go to get this. So, after I had this turned, I put the nut back on, and then I got a piece of about 2 1/4 inch stock, 56, 57 millimeter stock, this large end. And I cut internal threads on it to match this pattern that I had just made. Like I say, I was very inexperienced cutting threads. This was probably, well, I'm certain it was the first metric thread I ever cut. This lathe is set up to cut imperial threads, but just didn't take the lock nuts. This just didn't disengage the lock nuts while cutting this. Now, once I had this turned, threads in there and had it matching, I also put a couple slots in the end up here to use a spanner wrench, or in my case, just a punch, just to tighten that down. And I drilled and tapped 4 holes up here for the 1/4 bolts to go in. But I realized after I got this installed that this set of holes that I made right here, this inner set of holes, was exactly where the cover set. So I would have to take the cover off to use this at all. So I just simply went back and put 4 more holes on the outside edge, which is even better. It gets it further away, holds it further down the workpiece. But tighten that down good. Now the thing you've got to watch for, you can see a little step down here. The thing you have to watch for is when your cover so that it will fit back on. And it is not being a piece of bent sheet metal. It's not exactly centered on that spindle hub. So again, I turned this down a little bit extra, but I left a 1/4 inch thickness on this outer housing, and I still got my full-size bore all the way through. This again has come in extremely handy. Howard, I hope that helps you, answers your question. For the other viewers, what the lathe that Howard is looking at is the size larger than this. I believe this is 11/27. 11-inch throw, 27-inch between centers. I believe what he's looking at is a 12/28. Okay, folks, I think that's going to about do it for this Tidbits video. I've been running my mouth and ran out of time real quick, but I hope I've answered your questions regarding the power feed here on the surface grinder, and also any thoughts or ideas, questions you might have had on the outboard spider for the lathe. So take care, and I'll see you on the next video.